In today's video, we'll be looking at a powerful and easy to configure workflow template for dealing with scheduled script execution. These scripts, in today's example, will be coming from a GitHub repository. They will be retrieved and executed against remote hosts dynamically. But keep in mind, these workflow templates can be altered either by you or by Resolve to facilitate any type of scheduled script execution you may need. This workflow template is data-driven. In other words, there are tables that the user modifies so that the workflow knows which scripts to process, where they're coming from, and on which hosts they should be executed. I have one such table up on my screen right now. 3 rows here represent 3 separate scripts, all coming from GitHub, as we can see in the location column. The script type is also noted here as PowerShell, but of course, Python and other scripting languages are supported too. The path column calls out the specific path, the full file path, on the GitHub repository where the script resides. The repository owner column is also present, as it is required in order to pull these scripts dynamically in real time from a GitHub repository, as well, of course, as the repository name. Our other table contains a list of hosts. This list of hosts right now contains 3 remote hosts visible under the first column here on the left, and the script IDs column on the right lets us enter a comma-separated list of script IDs, which should be executed against these hosts. So for example, we see the first host should only have script ID 1 executed. The second should have IDs 2 and 3, while the third should have all 3. These ID numbers are coming directly from the row number on our other table. In this way, it's very easy to add new scripts to the table. And it's also very easy to add new hosts to the other table. Now let's look at how easy it is to configure the schedule itself within Resolve. Heading over to the Policy Actions page, I can click the plus sign here to create a new schedule. I can give it a name, a description, and I can select which workflow should be executed. I can also choose to log the workflow execution to a specific folder so that it's easy to find, filter, sort, and read later on. From there, I can select the cadence at which this schedule should run. So for example, if it were hourly, I could choose to run it at 12:39 p.m. every 15 minutes. Or you could say something like every 60 minutes. If I move to daily, I can do the same. Monthly, I can choose the time, or certain times in between and how often, or even the days. If I choose something like weekly, I can choose the time, the days of the week, as well as other custom time ranges. Now, you have additional options, such as stop workflow execution if it's running for more than a certain number of minutes, or skip execution if the previous execution is still running. You can also select a valid from and until time range so that you can create schedules that are only active for a few days, few weeks, months, or even years. Let's head back to the Workflow Designer view and take a quick look at how this scheduled script execution template works. Our first step is to use the built-in integration with Azure, more specifically the Key Vault, to retrieve service account credentials in real time. This way, we will have a service account with which we can authenticate to our remote hosts for script execution. Resolve is very flexible here, and we can use password vaults of any kind from any vendor, CyberArk, HashiCorp, BeyondTrust, you name it. Now once we have the service account credentials, Our template here enters a loop going through each of the hosts on the table we looked at a moment ago, parses necessary data from it. It then executes a child workflow or a sub workflow, passing some parameters to it, which we can see here. And in this example, we are going to travel down the left branch for scripts living in a GitHub repository. And here we can see the extraction of the script name, owner, path, etc. from the table, ultimately leading down to the step where we leverage the GitHub integration to retrieve the script, again, in real time, so that we're always working with the most up-to-date version of the script. It's important to note that you could, of course, store these scripts centrally within the Resolve platform. Alternatively, if we look at the unpopulated but can be built out right branch, we could handle things like Azure DevOps or Azure Pipeline, on-premise Git, or virtually any other place you may have your scripts stored. Heading back to the main workflow, depending on the script type, we'll travel the left branch for PowerShell, the right branch for Python, and as we can see, executing that remote code against the host is extremely simple. Afterwards, we are going to choose to email a report off that will contain all of the pertinent information on the script execution. It's important to note that at this step, we could be doing anything: building a spreadsheet, a PDF, populating a database table with results, or even an ITSM. It's up to you. Okay, we'll go ahead and execute this workflow directly in the designer view here to simulate as if this were scheduled based on the schedule configurations we looked at a few moments ago. Okay, our process has completed. We can see all of the verbose results right here in our log, and we see that an email has been sent. If we want to take a quick preview look at one of the scripts that was retrieved from the GitHub repository, we can do so by clicking on the result here in the execution log. In this case, it's a PowerShell script for retrieving top 10 processes on a system based on RAM memory utilization. Okay, let's go take a look at the report email. We can see here in the email that each of the 3 hosts is called out, along with how many scripts were scheduled to be executed for it. In this case, the first machine had 1 script scheduled, just like we saw in the table. We see the name of the script type, and from where it came, PowerShell from GitHub. In this case, it was a simple timestamp for when the Windows update process was last executed. Moving down to the next host, we can see 2 scripts were executed. Top 10 processes by CPU and by memory. And lastly, if we scroll down to the third host, we can see that all 3 scripts were executed. In closing, I'd like to point out that not only does Resolve Actions provide tons of pre-built templates for IT automation processes across all of IT, including scheduled script execution, as we're looking at here, but we take it further than your traditional batch scheduling or job scheduling system, in that the full power of automated workflows within the Resolve system is at your disposal. It can be as simple as executing these scripts, or all types of additional logic and steps can be included at any point. Running commands on any machine, retrieving data from any system, pushing data to other systems, whether we're talking about ITSM ticketing tools, monitoring tools, or servers of any kind. Resolve Actions Express is truly vendor agnostic and designed to cater to any use case. Thank you for watching.